I am Dr. Nalini, Computer Science Department, SA Engineering College, lecture captured on theory of computation. First, we are going to see about what is theory of computation. This is nothing but we are going to solve the problems in an effective way. Make use of computation. That is we called as theory of computation. For that computation purpose, we are using some algorithms also. We have three divisions for this theory of computation. One is automata theory, another one is computability theory, another one is computational complexity theory. First, we are going to see about automata theory. Automata theory is the study of abstract machines, and the computational problems can be solved using these machines in an effective way. These kind of abstract machines we called as automata. In this automata has two important things. One is state, another one is transition. States are represented in the way as circle, transitions are represented in the way as arrows. First we will see one of the type of finite automata. It consists of set of finite states and finite transitions from one state to another state. It has two types. One is deterministic finite automata, another one is non-deterministic finite automata. Now we are going to see about one simple sample example for this finite automata, that is switch. Here this is the finite automata design. Here two states will be there. One is off state, another one is on state. Already I told you about state means we will represent in the way as circles. And the transitions we represented in the way as arrows. Here in the switch is in off state. Then pressing the button, it will be changed into on state. Suppose if it is in on state, if we press the button, then it will be changed into off state. Like that it will be work. Now we will see the difference between deterministic finite automata and non-deterministic finite automata. In deterministic finite automata, transitions from one state to another state for every input symbol is going to be happen. That is deterministic. In non-deterministic finite automata, transition from one state to multiple next states is going to be happen for each and every input symbol. That is we called as non-deterministic finite automata. Empty string transitions are allowed in deterministic finite automata, but empty string transitions are not allowed in deterministic finite automata. Empty string transitions are allowed in non-deterministic finite automata. Backtracking is possible in deterministic finite automata, but backtracking is not possible in non-deterministic finite automata. In deterministic finite automata consumes more space compared to non-deterministic finite automata. Now we will see how the deterministic finite automata is going to be work. We will apply one sample string into the finite automata machine. Then it will be checking that string belongs to this design or not. Suppose if it belongs to the design, then it is going to be accept. Otherwise it is going to be reject that string. Likewise it will be working. In the deterministic finite automata, two important notations will be there. One is transition diagram, another one is a transition table. First we will see transition diagram. Transition diagram is nothing but this diagram is called as transition diagram. Already we see about this. In the transition diagram contains states, transitions and the inputs. Here see these circles we are represented as states. Already we told about that. So Q0, Q1, Q2 we called as states here. Transitions will represent in the way as arrows and the inputs are labeled in the arrows. Here the start is indicated as this is a start state and this double circle is indicated as this is a final state. This is the finite notation of deterministic finite automata. In the finite notation, Q, sigma, delta, Q0 and F will be there. Q means it is a final set of states. Sigma is the finite set of input symbols. Delta is the transition function and Q0 is the representation of the starting state. F is the representation of the final state, otherwise we called as that is acceptance state. In the delta function we have state and the inputs and what is the change it going to be happen, in which state it is going to be reached, that is the representation of P. Now we will see about the important thing, that is transition table. Transition table is the conventional tabular representation of functions like sigma, that is a transition function that takes the two arguments and returns another state. In this transition table, rows are represented in the way as states. In the columns are containing inputs. See, this is the sample example for the transition table. This is the transition diagram already we seen. In this transition diagram, we have three states Q1, Q2 and Q3. In this Q1 we called as starting state. In the Q2 we called as final state. Because of Q2 have double circle, so that we called as Q2 as final state. Already I told you in the transition table, states are represented in the way as rows and the input are represented in the way as columns. Okay, in the transition table, how we are going to fill means first we need to mention what all the states are present in the transition diagram and what are the input symbols we are going to use, that we need to be mentioned. See here, what all the states will be there? In the finite notation they are mentioning here. Q means finite set of states. So in this transition we have three states Q1, Q2, Q3. Next, input alphabets. What are the input alphabets here? We are using 0 and 1. What is the start state here? Q1. What is the acceptance state? That is final state is Q2 because Q2 has double circle. Now we will mention the transition table. Make use of this table. We can write the transition function. In this transition table, Q1 state. First we need to check with the Q1 state. In the Q1 state, make use of 0 input where we are reaching. In the Q1 state, make use of 0 input. We can reach the state as Q1, so that here we mention as Q1. Next, in the Q1 state, make use of 1 input where we are going to be reached. In the Q1 state, make use of 1 input. We are going to reach the state as Q2, so that here we mention as Q2. Likewise, next we will take as Q2 state with 0 input. We can reach the state as Q3, so Q3 we are going to paste here. In the Q2 state, make use of 1 input. We are reaching the state as Q2 itself. So Q2 we are going to place here. Next, in the Q3 state. In the Q3 state, make use of 0 input. We are reaching the state as Q2. Make use of 1 input also. We are reaching the state as Q2. Likewise, we need to fill this table. Make use of transition diagram alone. We can be able to fill this table. This is another one example for the transition diagram. Already I told you this is we called as initial state, otherwise starting state. These circles are represented as states and these arrows are represented as transition. This double circle state we called as final state or acceptance state. So in this they are mentioning as the finite notation. Q means what? Set of all states. So what are the states are present in that finite automata design? All the state we need to represent, that is the Q. Next, alphabet. Alphabet means what are the alphabets we are using in this transition diagram, that we need to mention. Here only two alphabets we are using, A's and B's. That alphabets we will mention labeled with the transition arrows. So here only see, only A's and B's we are using, so that A's and B's we called as alphabets here. Next, delta function. Already I told you all the states we need to mention in the direction as rows and the inputs we need to mention in the direction as columns. Next, we need to fill the particular state, make use of B input where we are going to reach. Like that we need to check and fill the entire table. Now we are seeing that initial state. What is the initial state of this diagram? Q0, because that is we represent with the arrow mark initial state. Next we are going to see about F, that is final state. Which one is the final state of this diagram? Q4. So we mention as Q4 as the final state. Now we will see with one sample string how we will check that the string is belongs to this design. Suppose if the string is belongs to the design, what has happened? How it is going to be accepted? That we are going to check. The input string checking will happen from left to right only. So first we are going to take the first input, that is A we are going to take first. So in the A input we need to start from the transition diagram starting state itself. So in the starting state Q0, make use of A input where we can going to reach. In the Q1 only we are going to reach. Okay. So now we are in the state as Q1. make use of A input, we are reaching the state as Q1. Okay, now we are in Q1. Next we are going to take the next input, that is B. So make use of B, we can reach the state as Q2 because we are in the state as Q1 first. So make use of B input, we can reach the state as Q2. Now we are in the state as Q2. Next we are going to take the next input, that is B. Okay. In the Q2 state, make use of B transition, we can reach the state as Q3. So now we are in the state as Q3. So next we are going to take as next input, that is A. Now we are in the state as Q3. Make use of A input, we are going to reach the state as Q4. Okay, Q4 is the final state and the acceptance state. Next again we need to check for the next input. There is no input. But finally we are in the state as final state. Right, there is no input. In the time we are reaching the state as final state. For this meaning is what? This string belongs to the language. It is accepted. Okay. Suppose if it is not accepted, rejected, then how we know that? Okay. So now we will see one rejection case. Here also we will take one sample string. We need to check with left to right only. Okay. So first we need to start with A. In the diagram we need to start with the starting state Q0. Make use of A input. We are going to reach the state as Q1. Okay. So next we are going to take the next input, that is B. Now we are in the state as Q1. Make use of B transition. We are going to reach the state as Q2. Okay. Next we are going to take the next string, that is A. Okay. Now we are in the state as Q2. Make use of B input. We are going to reach the state is what? A. We are reaching the state is what? Q5. Next there is any input will be there? No, there is no input. But we are in the state is what? Q5. Q5 is what? It is one of the states in the transition diagram. So in this case, we are going to reject this string. This string is not belongs to the language. There is no input. In that time, we are reaching the state as final state. Then only the meaning is it is accepted. Instead of final state, we are reaching any other state. That is the case as a rejection only. Okay. Thank you.